I'm Wojtek, and as Daniel mentioned, I work on open source libraries. One of them is Rec. I work at Dashbeat, and also as Daniel mentioned, we help companies adopt and run Elixir in production. And so at Dashbeat we do two things. We work on libraries, grow the open source ecosystem, and work with these companies. And as we work with them, we see how they use libraries in production. And so if there are some problems, if there are things to improve, we get to learn that and then put that back into the libraries. And so I think this is a pretty nice arrangement. And I am very happy to say that as of today, some of our clients are using Rec in production, and as I was hearing on the event, some of you are using Rec as well. So this is pretty cool. Yeah, let's talk about Rec. Let's see Rec in action. This is my favorite, let's say, hello world of Rec. We can just mix install Rec, and we are ready to go. We can call rec.get with a URL, and we are gonna get a response back. So Rec is an HTTP client. You can get any HTTP things, but yeah, most commonly it would be APIs. So this is an API, a JSON API from GitHub. This is the response that we would get. Some basic HTTP stuff, status, headers, and body. Instead of making the request right away, we can build up the request struct, not make the call yet, and then later on make it. And so you'll get the same result, the Rec response. And so we can look at the headers. They are a map, so you can use the access syntax. And we have the body. I showed the content type header. So here is application JSON, and when Rec sees this particular header with this particular value, it's going to automatically decode. And so the body is a map, and yeah, we can kind of dig into the map, so we can grab the description, and yeah, Rec is a batteries included HTTP client for Elixir. The batteries included, the analogy is you buy something, you take it out of the box, it has batteries included, it's ready to go. You don't have to do anything else, so it's like the good out-of-the-box experience, right? And what I mean by that is, so in the software world, Python would be commonly described as having a batteries included standard library. It has a bunch of things that people would commonly use, and so that was my goal with Rec. It has a bunch of features, which I'm not gonna go through, but just to give you an idea, the kind of things it does is, if we got a response from the server, it was compressed, we would automatically decompress it. If it was encoded, like I showed with JSON, it would automatically decode it. There is a functionality for working with URLs. We support request body streaming and response body streaming. And there are some testing recent additions as well. But to continue with the analogy, we have batteries included, but we have replaceable batteries, meaning most of the features of the client can be replaced. You can take existing things and reuse them in other ways. And so, yeah, to talk a little bit about the internals of Rec, let's say we built up the request struct with these options, with the URL, and let's say we don't want to. So one of the features is when we get a response, which is a redirect response, so HTTP status in the 300s range, Rec will automatically redirect, but let's say in this particular case, we don't want to automatically redirect, so we set the redirect option to false. So what happens? What is happening under the hood? What is the data that we work with? So we get the request struct with the method get, with the URL, so, which we have given. Let's say the headers are for now empty, the body is empty, and then we store the options. So redirect is a custom option, and we store it. We don't, we keep it for late. It's gonna be obvious later why we do that, but we keep options around. And then inside the struct we have steps. So steps are the basic, it is both how Rec is implemented, all of the features are steps, And this is how we also can extend step, which we're gonna see. But the important thing here is we have all of the steps in order, and steps are just functions. And so each feature of the client is basically a function, and so it has its own documentation, for example, usage examples. You can look at each function individually and see what it does. So we have request steps, so they happen before we make the network call. And after we got a response from the server, we get response steps. So let's say we got an HTTP 500 or something like that, we can, Rec will automatically retry using the retry step. If we got HTTP in the 300 ranges, we would redirect. If the body is compressed, we would decompress, and so on. If you got an error from the server, network error, network timeout, there are error steps for that. At the moment, the only one is to retry, but you can add custom steps like maybe some custom logging or things like that. And in order to extend Rec, we just write functions. So this is a very simple step. It takes a request, it returns a request, and then say we just output the request URL or some other piece of data. And we add it to Rec. We extend Rec with this step by calling append request steps function with the name of the step and the function. The word append is important. Append, add it to the end of the list. There is also prepend, so add it to the beginning of the list. The order of the steps matter. You know, it only makes sense to decompress and then decode body, not the other way around. Yeah, the sort of, yeah, because this order matters, it is kind of important that Rec ships with all of these features in a particular order, so you basically don't have to worry about it too much. So my plan for this talk was to show you building API client from scratch and talk about extensibility, which we covered a little bit, but also performance, resilience, observability, and testing. And as I was preparing the talk, so apologies for a little bit of maybe bad marketing, I decided to skip these parts. And the reason is pretty simple. Finch and Mint basically take care of that. So I could give a whole talk about these aspects. So I cannot give justice to these important topics here. But yeah, basically Rec uses Finch and Mint, which have excellent performance. It's basically as fast as it gets. They help with resilience, and so Finch also have observability. Finch emits telemetry events, but also with Rec, because it is extensible, it is easy to extend it yourself to emit telemetry events and things like that you want. I will cover testing though. Another reason that I skipped these topics is that there is a fantastic talk from last year's Orlando conference by Christian, who was talking how they use Rec and Finch at cars.com. So definitely do check it out if you are curious about these particular topics. I think he made a way better job than I could talking about these topics. All right, let's see Rec in action. Let's build an API client. Let's build a client for Stripe. That's an integration that I did somewhat recently. And before building an API client, a pretty prudent thing to do is to check if one already exists. So if we check for Stripe on Hex, by far the most popular project is Stripity Stripe. And I would consider Stripity Stripe to be an SDK, software development kit. I couldn't find like a singular definition, but the way I think about it, SDKs are sets of APIs and tools to interact with usually large or like really large platforms. So some examples of SDKs are, so GitHub maintains official SDKs that they call them OctoKit, and there is a Tentacat kind of SDK in Elixir, and same for Stripe, AWS, and Google, and many other services. In terms of handling these large platforms with SDKs, there are kind of two approaches that people do. So kind of handwriting these libraries. So that's, for example, what AWS does. They handwrite the functions which is there are trade-offs with that. So for example, if you handwrite all of the functions, then well, did you write all of them, right? Like these APIs are huge and they keep evolving, they keep adding new things. So if you handwrite, you would always play the catching up game. So the other approach, by far the most popular, is to automatically generate these APIs. So that's, for example, what AWS does, the Google APIs, the Stripe as of version 3. So the idea is there is like a general, like an abstract description of the services, and based on that, there is automatic code generation. And as with anything non-trivial, there are trade-offs with that. So here's an example. I just picked Stripe just because I was working with Stripe. So here's some code from Stripe for creating a checkout session. That's one of the things that you can do on Stripe. Yeah, we have a little bit of documentation. We have some type specs, which are pretty cool because we have some more data here than the tooling could take advantage of that. Maybe editors could do autocomplete. We have documentation created out of that. And here is even the rendered documentation of this, right? So we have the Stripe checkout session module. There's a create function with a bunch of these options, which is pretty good. Like, I think this is actually really good. And then, yeah, we have a lot of options there. And then there is like a option locale, and there is a bunch of those, right? And so like, I would say it is not the best experience to like throw all of these locales, which would be like on most functions, right? So then maybe the developers should be like, oh, maybe this locale should be a particular type. So you have to do like a custom change. And I think the problem with this SDKs is that to have like a really good user experience, you have to make a ton of these changes. And then the APIs change upstream as well, so you always kind of like play this catch-up game. There is a big problem with them as well. Yeah, again, these APIs are pretty huge, and so like if you only need to maybe have a function or two, I would say it is pretty wasteful to bring in literally hundreds or thousands of modules. On this conference a couple of days ago, someone told me that they were using one of the libraries for one of these big platforms. A single package was, for a single service, was bringing in a few thousand modules. And if you have a few thousand modules, you have to compile them, which, to be fair, you only have to do once. When the VM boots, it loads the code, which you only have to do once in production, but in tests, every time you run tests, you have to load them, all of these modules, which takes time. And more importantly, every time after you have loaded the modules stay in memory, taking up memory space. Yeah, so more data from the library. So yeah, I think there are trade-offs with these software development kits, and so I would like to propose a very radical idea to maybe keep the SDK name because I think it's pretty catchy, but have something maybe a little bit simpler. So simple development kits. You could argue that simple is pretty subjective, like how to say what something is simple. So maybe for something a little bit more objective, I propose small development kits. So let's take an example. This is a Stripe integration that we use at the Dashbit. There's a new function, so that's going to build up the request struct. And so it uses some of the features from Rec. So we set the base URL option, so it's going to keep this base URL around, so you don't have to repeat it. It has some authentication, so here we just put the bearer token from the application env, and now we add some custom steps. So here's a very simple custom step. The idea is we look at the request and pattern match. So, if the method is get, which would be the default, and the body is non-empty, which would not be the case for get requests. Get requests should have an empty body. So the idea is, you didn't even specify the method, so you got the default, but you set the body. The intention was you wanted to make a post request. So this is what this step does. It just changes the method to post. And then at the end, we merge any additional options that you may have given to the function. We also have a kind of entry point functions, so request and request bank. And under the hood, they just call the new function, which sets up the request. And then otherwise just calls rec.request. And this is pretty much it. So pretty small, I would say. Let's see it in action. I have a customer ID here, so I can do request with the /customers/ID, and I can get the body field from the struct and destruct it and destructure, and so I have the name of the customer. This is it, right? On one hand, like with SDKs, it's nice that you have all of these functions because you can like search for what you need, get customer. Maybe you can even ask ChatGPT, what is my function name to get a customer, but like you can also do this. And as a matter of fact, so one important thing about Stripe IDs is, so this Stripe ID, CAS, it starts with CAS _. This is pretty cool, what they do at Stripe. Every object ID has a particular kind of pattern. It has a unique prefix. So when you just look at an ID, you can already tell what it's about. So this is an ID for a customer. For subscription, it would be sub, and so on. And so we even use this piece of information to do this. When you give this module a URL, we first parse it, see if it starts with a sub, it's going to use the subscriptions URL. If it's a CAS, it's going to use the customer's URL. And so, yeah, we can just do this. You get an ID, a Stripe ID. Let's say you got an exception, something went wrong. This is the ID. Yeah, you can just give it to this function. Again, like it's nice to have all of these functions, get customer, list customers, but like, yeah, like you don't need that. You have a custom ID, you can get it, and I mentioned the custom step that updates the method to post. This is how we can do updates. So rec has a form option, which takes a key value and does the form URL encoding of the request body. Yeah, we basically set request body to this. This is enough to make an update. We get the ID of a customer, we change the name to Bob, we grab it again, it is updated. So again, we don't have to find like a update something function. We just take an ID, we update it. Yeah, a very important part is that we can hit any Stripe URL with this, but we can also pass custom options. And this is the reason that we keep options around. We want to make this rec makes decisions off of these options as late as possible. So all of the custom steps, all of the custom options were running before they were, all of the options are kept around, and then we merge these options that were given here. And so very late in the process, you can still use all of the rec functions. You can disable retries, for example, or you can set some different authentication tokens. This is really useful when debugging. And yeah, this is pretty much the whole module. This is what we use for Stripe, and it has been working very well for us. So for me, like when building API client, that's important part. The other part is testing it, making sure it works. And so I'm gonna quickly go through three types of, really kind of two types of testing that we do. So explicit contracts, local stubs, and ownership stubs. So explicit contracts. There is a very well-known blog post by Jose. It's kind of wild to see that it's almost a decade old. It's from 2015, which is yeah. So definitely do check it out if you somehow didn't read it yet. I'm gonna read one excerpt from the blog. So it's about mocks. Like people sometimes will just, yeah, okay, I'm interacting with this third-party system using this function. I'm just gonna stub it out, or mock it out and move on, right? There are trade-offs. So I'm just gonna read this excerpt real quick. So, because a mock is meant to replace a real entity, such a replacement can only be effective if we explicitly define how the real entity should behave. Failing this, you will find yourself in the situation where the mock entity grows more and more complex with time, increasing the coupling between the components being tested. But you likely won't even notice it because the contract was never explicit. So, you just keep adding stubs. I'm just gonna stub this function, this other function, and then you have all of this implicit coupling that is actually very hard to maintain in the long run. And so the idea with explicit contracts is to have a, Jose kept saying that functional programming, one of the descriptions of functional programming is to make kind of difficult part explicit. And so I think this is that as well. The boundary between your app and a third-party service is often, or like mostly, it's very often the source of most problems in your app's timeouts, network flakiness and stuff. And so making that explicit is very helpful. All of the code around that important integration is going to live in these modules. And so first, we want to have an explicit contract. So let's define it. So it's going to be a behavior with callbacks. So all of the aspects of Stripe that we use in our app, we would have a function, a callback for them. So many callbacks. And then what we do is at compile time, we grab the module that is implementing the callbacks. And then we have delegates for them. So sometimes we would see that people would have a different module for the contract and then the different module for calling the implementations. I like to mix them into just one. In the configuration, by default, we would set the callback, the implementation module to, let's say, Stripe API rec. So that's a module that uses rec to make these calls. But in tests, we would use something different. And the implementation being, we implement the Stripe API behavior, and then for each of the functions, each of the points of integration with Stripe, we would use the Stripe module. So here is very obvious, it's just using the customers, but think about you have a domain concept in your contract, creating a product which has a particular price, which has a particular quantity and stuff like that. It is very nice to encode that information in a place in your application as opposed to in a controller or a live view or something. And then in the tests, what we can do is change the application environment to use a mock implementation and use something like mocks to be able to swap the implementation in tests. And so in a test, we may do something like this: mocks stub list customers functions to return an error. This way we can check for errors, or rather, we can see what our system does when it encounters errors. So I think explicit contracts are a very nice starting point. I think there is a real value in making that important part of your application explicit. The problem with contracts, though, is that they can be very helpful, but if you kind of get them wrong, they can become a bit of a liability. They can hold you back. So sometimes it is useful to not have these contracts, but also not do mocking willy-nilly, but have something more structured. And so for that, I'm going to show you the other approach and start with local stubs. Here is a request that we have seen before. It hits the network. And now what we can do is Rec has built-in integration with the plug ecosystem, so to speak. When we set the plug, so plug can be a module, but it can also be a function. So here what we do is Rec, instead of making the network call, instead of getting the information from the network, it's going to get the information, the response from the plug. So it's just going to evaluate this plug. And the plug is just a regular plug. We set the application, the content type, we set the response, we encode the response. So it is like, instead of hitting the real network, the real server, we hit this stubbed. We hit this like a test server, but we control it using the plug API that we all know basically. And the name is local stubs because we pass the plug option to the request call. Now, in most apps, you wouldn't probably call this low-level module like directly in like your controllers, in your live views. Usually, you would go through something like a maybe context, like at work we have a billing context for all of the billing-related things. And so, if you want to set this plug option, you kind of have to pass it through all of the layers of your system, kind of pass it in the live view, pass it through the context, pass it through some other helper modules and stuff. If you can do it, I would say this is the preferred option, but it sometimes gets really tricky, especially if the function function in the middle of this layer, maybe it accepts some options of its own, so it gets kind of messy with this. And so here is the kind of maybe extension of this local stubs idea, and this is of ownership stubs. So we have seen mocks before, we have seen local stubs. So here is like a bit of both, if you will. We are just going to make our production code just a little bit more flexible. Actually, it's going to accept even more options, global options from the application env. And then in tests, we can set the plug option that we have seen before. But instead of setting it to a function, we can set it to this tuple, rec test and the name. And the idea is rec test is actually a plug that accepts a name of a thing that you are stubbing. But basically, what this does is rec is going to make a request again. Instead of over the network, it's going to make it towards a plug that you can control in your tests. So let's take a look at this. Instead of passing the plug option, we do nothing because in tests our API is going to use that plug option, and now we have a special function called rectest.stub. It uses the name of the thing that you are stubbing, and then you can use the familiar plug API. Under the hood, so the name is ownership stubs. Ownership so this uses the same foundation that Mach uses, very similar to what Ecto Sandbox does. It's an ownership mechanism. Basically, the test process owns like some particular resource. So here is the test process where the process that you run tests owns like this. It owns the implementation of this stub, if you will, and you can have concurrent tests. So basically, this test is going to have this implementation. Some other test is going to have some other custom implementation, and they don't, and they can run concurrently. They don't conflict. I could probably give a talk about the ownership mechanism. It is pretty cool. There is a process tracking. You know, there is a way to associate processes with each other. I think it's really cool how it works under the hood. But you don't have to worry about it. You just use the stub function and you can move on. Actually, stubbing these JSON APIs is so common that instead of having you write setting the content type, setting the JSON, there's a little rectest.json function which takes the con and a thing that you want to encode to JSON, and this is basically it. So it's really easy to create stubs for your servers and test how they behave. So the summary, rec is batteries included, HTTP client. So I wanted to have features that most people would use most of the time. All of them are functions. You can take them, reuse them, rearrange them in different ways. You can see how they work. You can write your own functions and plug them into the into your API clients. I proposed the radical idea of, instead of taking on these huge dependencies that are hard to even think about sometimes, to write something from scratch that is tailored for your particular application. You have like you have to write all of the code, but all of the code is like 20 lines, so it's not a huge deal. And you have full control, so it is up to you how you want to test it. For example, with these SDKs, it's sort of up to SDK what kind of affordances it gives you. But here, if you have full control, it is up to you. And then I went over the types of testing that that I recommend. This is pretty much it. Thank you.